In this week's video newsletter, it's Docker and Kubernetes for the liberal arts inclined. We can all read a textbook definition of containers and container orchestration, but we're going to bring them to life with a little help from Wired. Plus, Steve Jobs didn't invent the GUI, Xerox PARC did. The cloud is under the ocean, and the Chinese cloud is not the same as the American, and vice versa. What's up, everyone? I'm Alice from SaaS Savvy, where you learn to talk tech, not code it, so you can talk about all kinds of other stuff. Enough to Be Dangerous is my Substack newsletter, and this is the video edition. We talk tech, starting with a shortlisted tech-related article, and then do a high-level deep dive on a technical topic. I comment on 3 curated links and throw in a just-for-fun piece of content, too. A video essay from yours truly rounds us out with musings on everything from growing up in the internet age to eye-rolling at Silicon Valley tropes. In the description box below, you will find links to all the reference content plus a link to my Substack. So please throw this video a like and subscribe to the channel, and let's go. Our shortlisted article of the week is The Man Who Would Build a Computer the Size of the Entire Internet from Wired. When you start learning about cloud-based software, you quickly learn that there's a front end that displays the user interface, or UI, a back end made of a web server, an application server, and a database. The web server hosts static files like HTML and images. The app server hosts the application source code, and the database collects all the data that the app collects. The front end sends requests to the back-end app server, which hits up the database, which sends back a response. Rinse and repeat. This front-end to back-end web server app server database is a very handy assessment for a high-level understanding of software architecture. But as you delve deeper into all things software and cloud, at some point you'll come across containers, Docker, and Kubernetes orchestration, and you'll realize that there's a lot more going on than just this simple backend trifecta. Now, containers, Docker, and Kubernetes are nothing that you can't understand, but context is very helpful to grasp what has made them so groundbreaking in the world of software as a service and distributed systems like Amazon Web Services and Google Search. A few months ago, I was really struggling to find that context, specifically as it pertained to SaaS. Quote, "A container packages code and its dependencies so an application can run quickly and reliably across many computing environments." These words make sense, but why? Why does an application need to run across computing environments? Isn't it just sitting on an application server doing its thing? I needed someone to give me a fuller picture I couldn't get from SEO-optimized blogs hawking developer tools or coding bootcamps. I needed some literature, for someone to gracefully provide me some meaningful background. So I turned to Cade Metz, my favorite New York Times tech journalist who was formerly at Wired. He has the gift of blending the eloquence of an English major with a truly grounded understanding of web technologies, taking tech beyond simple definitions to a fuller dynamic picture. As he explains, a Google application like Gmail doesn't run on a particular server or even a select group of servers. It runs on the data center, grabbing computing power from any machine that can spare it. There are many use cases for and benefits of containers, but I'll focus on software applications here. See, as applications grow in traffic and users, they need to scale to remain available and performant, i.e., up and running. Developers can scale an app vertically by running it on more powerful servers, but at a certain point, the server is going to tap out. The more common alternative is to scale horizontally, which involves replicating an application and database across many servers and using software called the load balancers to divvy up traffic. The tricky thing is, all these servers in the mix might be coming from different manufacturers, for example, Microsoft versus IBM, and may run different operating systems, for example, Linux versus Windows Server. You need to run a different version of the game The Sims to run on your Mac versus on a Windows PC, and servers in a data center running SaaS applications are no different. So how can developers ensure that their code will run on whatever machine it lands on when replicating and scaling across servers in a data center? Enter containers. Just like shipping containers box up stuff so that they can be moved efficiently across boats, ships, and trains, software containers box up an app so it can run on any machine. Writes Metz, quote, A Docker container holds not only a software application, but just about everything else that an application needs to operate. All of the software libraries and other application-related code normally included with an operating system. These additional software libraries are known in developer parlance as dependencies. In other words, containers package up code and all the things that it needs to run so that you can plop an app on any server and boom, let it rip. Docker is a platform built to allow developers to containerize their applications. Containers can quickly get unwieldy, so orchestration tools like Kubernetes were built to manage and coordinate them across machines in a data center. This Wired article was written in 2013 when the company Docker was ushering in a new and improved open source version of containers that would go on to transform software development and usher in the DevOps movement. While over the past decade, the company struggled to find the right commercial model, according to the information, they've led quite the comeback and now sell a desktop hub that helps developers build apps with containers. The Technical Underbelly, a high-level deep dive into a technical web SaaS or cloud concept. And today's concept, naturally, are containers. Containers package code and its dependencies so that an application can run quickly and reliably across many computing environments. Docker is an open platform for developing, shipping, and running applications and allows developers to package their applications into a standard container format that can run on any platform. A Docker container is a container built on Docker. Prior to the container renaissance of 2013-ish, software development was a more time-consuming and complex process that involved manually configuring software to run on different operating systems or platforms. Now, with containers and platforms like Docker and Kubernetes, developers are able to write code once, package it into a container, and then run and manage the application across multiple platforms. Here are some things that you should know about Docker and containers. Docker containers allow developers to more easily scale applications across different computing environments, from the local laptop to the data center to the cloud. For example, a dev may code an app on their local laptop that's running Mac, but need to deploy, i.e. make available, to a remote test environment that runs Linux. Before containers, developers would have to refactor the code from Mac to Linux. With containers, the app is ready to run on Mac, Linux, or any other app without additional tweaks. Docker containers are highly portable, i.e. they travel well and can be deployed to any platform or computing environment. This allows developers to deploy applications in different cloud environments consistently. And finally, in case you were wondering, Docker containers are lightweight when compared to virtual machines. Containers on a host share an operating system, as opposed to each bringing their own to the table like a virtual machine does. The operating system itself is heavy, and if containers had to bring one to each deployment, it would slow down the startup of the application considerably. It's time to stay savvy with this week's curated links and commentary at the intersection of tech, business, and culture. History of tech. The legacy of Xerox PARC, Silicon Valley tech innovator PARC, celebrates its 40th anniversary from the Los Angeles Times. The personal computer, object-oriented programming, an early graphical user interface, the predecessor to Microsoft Word, Ethernet, the laser printer. These all have one thing in common. They got their starts at the hands of trailblazing scientists and engineers at Xerox PARC. Back in 1970, Xerox was flush with cash as its status as the #1 photocopier business on the block. However, like Instagram and Facebook today, they feared losing their dominance to new technologies that might sully their unfettered growth. Like fellow monopoly corporation at the time, AT&T, so big in fact, it was referred to as Ma Bell, they bankrolled research and development not just to discover new photocopying techniques, but to create new groundbreaking technologies entirely. Where do you think Steve Jobs got the idea for the graphical user interface? Despite failing to find a working commercialization model for the new inventions, PARC still lives on to this day. Technicalities. The global internet is powered by vast undersea cables, but they're vulnerable. From CNN. It's important to remember that the internet is not magic, and tech CEOs are not celestial, all-knowing beings. The internet is a very physical beast made up of fiber optic cables, copper, wires, towers, data centers, racks of servers. And while the reigning metaphor for data in the internet is up in the sky as a cloud, it's actually all going down under the sea. There are millions of miles of underwater cables transferring all our tiny bits of data across the planet to various exchange points located around the globe. Undersea cables, part of the mere mortal universe themselves, are subject to disruption from unassuming sea trawlers, submarines, Mother Nature, and concerningly, espionage. Like the internet network itself, data traffic is spread across multiple routes, and luckily there's not one single point of failure. Head in the Cloud, The State of Chinese Cloud by Lilian Li on Substack. In this part 1 article, Lilian Li explores the Chinese cloud market and adoption of the cloud by Chinese companies. Although Alibaba and Tencent public clouds are making strides, overall adoption of cloud by Chinese companies is still second to that of the United States. Li puts forth that the, quote, Chinese cloud market is still in its installation phase of cloud and will require additional years to hit its stride in the S-curve adoption. Li lists the following as challenges for cloud and SaaS adoption in China. 1. Distrust of the public cloud. Chinese firms are wary to store their data with a third party and prefer private cloud environments that they control themselves. 2. Lack of cash and willingness of adoption for small, medium-sized businesses. Li wrote another article on how the fact that low-cost human labor in China has meant it's often cheaper to just pay humans to do tasks than it is to buy software that automates them, especially when cash is low. And 3, enterprises demand high levels of customization. Migrating from an on-premise environment to the cloud is an opportunity to reassess, not just do a lift and shift, bringing the old way of doing things to a new environment. That's time and resources. McKinsey highlights that consumer-facing Chinese companies have eagerly eaten up the seemingly limitless access to computing power as offered by the cloud. ByteDance even launched their own public cloud services, Volcano Engine, in 2021. McKinsey cites the next frontier for cloud as the country's large industrial and manufacturing sectors. In this week's Alice Egan is SaaS Savvy, I read a Medium post I was compelled to publish in the reckoning of 2017. I hope you check it out. Otherwise, thanks for tuning in to this week's Enough to be Dangerous video newsletter. Please like this video and subscribe to the channel, and I will see you next Friday when the video edition comes out. Till then, stay savvy.